In this video, we are going to learn how to graph translations of a quadratic function. We're going to graph each of these functions and describe how it was translated from f of x is equal to x squared. Now, as a reminder, I put what the horizontal translation and vertical translations look like when you look at one of these functions. Here, when you subtract a value on the inside, it shifts it to the right. If you add a number on the inside, it shifts it to the left. If you subtract a number on the outside, it shifts it down. And if you add a number on the outside, it shifts it up. Now, let's break down what that translation looks like with this problem point by point. So if I'm looking at -2 on the original f of x equals x squared function, it would be 4. But if I plug the -2 into this function, -5, I would get 4 minus 5, which would be -1. So -2, -1. If I plugged in -1, which originally was 1, I would get 1 minus 5, which would be -4. Plug it in 0. I'll get 0 minus 5, which is -5. Plug it in 1. I'll get 1 minus 5, which is -4. So 1, -4. And plug it in 2, which originally gave me 4, will now give me 4 minus 5, which is -1. And I can see that my parabola forms down here. If I look at every point, how it moved, every point went 1, 2, 3, 4, 5 down for every single point. So it looks like this entire graph just translated 5 units down. So we'll say it's a translation 5 units down. But now this could be tedious to do every time, but now we notice that this is just a translation. Again, we subtracted 5 on the outside, so we went down. We can just imagine what our original parent function would look like and just shift it where it needs to go. So for this next problem, instead of graphing it first, we can actually point out that it is a translation, because we're doing x squared plus 3. It's a translation 3 units up. So if my graph was originally at 0, 0, 1, 1, I'm just copying what the original parent graph is. 2, 4. Then every one of these points from that parent function would all move up 3 units. So the vertex goes up 1, 2, 3. 1, 1 goes up 1, 2, 3. -1, 1 goes up 1, 2, 3. The other ones go off of the grid paper, but we can see here that our graph has shifted upwards. So right here. So everything has shifted upwards for this parabola. Now let's look what happens when we shift horizontally. So now we're subtracting 4 on the inside. So that means we should have a horizontal translation to the right 4 units. So translation right 4 units. So again, if I imagine my original parent function, which would be 0, 0, 1, 1, -1, 1, because again, these are symmetric. 2, 4, and -2, 4. I'm going to shift every point to the right 4 units. So 1, 2, 3, 4 for my vertex. 1, 1 goes 1, 2, 3, 4. 2, 4 goes 1, 2, 3, 4 to 6, 4. Negative 1, 1 goes 1, 2, 3, 4 to 3, 1. And last we have negative 2, 4 goes 1, 2, 3, 4, and it lands on a point it used to have. But now you can see our parabola has shifted to the right 4 units. Now before I do the last example, you'll see that even though I'm shifting this function around, it still maintains its symmetry everywhere we go. So if I were to draw in the axis of symmetry on all of these, just following the blue curve, you're going to notice something interesting happen for the horizontal translations. Because for both of the vertical ones, as you can see on my left as I'm drawing this last one, they just kind of stayed at x equals 0 as normal. Because I only shifted up and down, but now when I shifted to the right 4 units, my axis of symmetry went from x equals 0, which would be the y-axis, to x equals 4 as my new axis of symmetry. So we can actually use this to our advantage. So since we still will maintain this axis of symmetry, then when I graph this next function, first I indicate what the transformation is. So it's a translation. I'm adding on the inside, so left 1 unit. So now, before I start graphing, I can already tell that my axis of symmetry will be left 1 unit. I can plot that first. And now when I go to graph, I know that my original function, parent function, is at 0, 0, 1, 1, and 2, 4. Since I know where my axis of symmetry is, after I translate these points, I can just reflect them as well. So here I have 0, 0 goes left 1, 1, 1 goes left 1, and 2, 4 goes left 1. And all of these points can just be reflected across the axis of symmetry, 1, 2, 1, 2, to create my new parabola. You'll see here that I only use half of the parent function. That's really all I needed, because I know these graphs are symmetric. Now lots of things take place here, but the big thing you need to notice is that we just shift every point with a translation. And this can work on all functions, and you'll start to see a really clear pattern as we go through all these functions throughout the semester. And that is how you graph translations of a quadratic function.